In this video, we're going to explore the idea behind limits. It's actually a very easy topic. There's a lot of in-depth maths in the background as to what's really happening, but I've seen the way that they test the exams for grade 12 and the way they explain it in class. There's an easy way to do this. The more in-depth stuff they only introduce typically in university level. So all you do is you plug the limit value into this expression, and if you don't end up with any errors on your calculator, then everything is fine. And so what you can do is you can just try plugging it in first. So you could just say equals to 0 squared plus 3 times 0 plus 4. And if you do that on the calculator, the answer is 4. And that's it. That's how you do limits. Obviously, there are going to be many instances where that doesn't work, but always try that out first. So in this example, we should always try plug in the value straight away. So let's do that. So we'll say like that over there. But then when you press equals on your calculator, you're going to get an error. Now the reason for that is that at the bottom over here, if you're plugging minus 1 into the place of x, well, you're ending up with a denominator of 0. And that is the main area that limits will catch you, is when the denominator becomes 0. But then if you get a question like this in the test, it has been designed in such a way that the denominator can be cancelled. So let's see how that would. So now we're not going to plug minus 1 in yet, so we're going to carry on with the question. So now here's where teachers get the department is very strict about this. You have to keep saying equals to limit x goes to minus 1, and you have to keep writing that until you actually use the minus 1. And sorry, if this isn't clear what I'm doing here, it says x and then there's an arrow, and the arrow is pointing to minus 1. So it says x is going to minus 1. Okay, so now what we're going to do is we're going to have to do a few things. So what could we possibly do at the top? Well done if you realize that we can factorize, and so that's a nice easy trinomial. They'll always design them as fairly easy if they need the denominator to cancel. So that's just going to be x minus 4, x plus 1 over x plus 1, and so that cancels, and so then we can just write equals to lim x goes to minus 1 of x minus 4. Now we can put the minus 1 into the equation, so then we can just do this. Now you don't have to say lim anymore because we're going to use the minus 1 like that, and the answer is minus 5. See, so it's easy. If you get an error on your calculator, then you just have to do an extra step and then just plug the value in. Okay, so here we can try plug everything in, but we can clearly see that there's a 0 at the bottom, and so if you just plug there's an x at the bottom, and if you plug 0 into that, you're going to end up with a 0, and you can't have a 0 in the denominator. So then all that you do is you factorize. So then we're going to have to say equals to lim x goes to 0, then you take out x as a common factor at the top, and then you're left with x plus 3. The x's then cancel, and so we can say equals to lim x goes to 0 of x plus 3, and now we can just plug the value in, and so that's going to give us 0 plus, so that's in bracket, plus 3, and 0 plus 3 is just 3, so the answer for that one is 3. So in summary, plug the value in. If it doesn't work, factorize or do something that will help it to somehow, there'll only be one or two things that you can possibly do. You simplify it like that, and then you plug the value in, and if you don't get an error on your calculator, then it's all fine. Here's another one. So we'll start by just plugging the value in, and if you plug it in if you plug 1 in at the top, you end up with 1 minus 1, but then at the bottom you end up with 1 plus 1. Now this is okay because we end up with a 0 at the top but a 2 at the bottom. That's fine. 0 divided by 2 is just 0. What you don't want is you don't want a 0 at the bottom. That's where the error comes in on the calculator, and that's when you're going to have to do something else. And here's one last one. So if we plugged 2 into this expression, well, at the bottom you would have 2 minus 2, which is 0. Now that's a problem, and your calculator would have given you an error. So then we have to do a few things. So now, because we're not using the 2 yet, we have to keep writing this lim x goes to 2. That's very important. Then at the top we have a difference of squares, so it can become x minus 2, x plus 2 over x minus 2. Those can cancel, and so we're still not using the 2 yet, and so that's going to say x plus 2, Now we're going to use the 2, so we don't have to write lim anymore. So we just say 2 plus 2, and that's going to give us 4.